Hello again, students, and welcome to my class. Today, we will start with chapter 4, which is the gaseous state. Okay, so let's start. Chapter 4 is entitled The Gaseous State. Okay, what about the objectives of this chapter? First, we must recognize some characteristics of the gaseous state. Verify these characteristics using experimental evidence. So we will do a certain experiment in order to know these characteristics. So in order to know the characteristics of gases, we will perform two, three experiments to deduce what are the characteristics of these gases. We want to prove that gases have mass. We want to define the term fluid. What's fluid? And finally, we want to distinguish a gas from a solid and a liquid. Let's start first. So we have covered in chapter 1 the solids and liquids in details with their characteristics and everything related to them. Now it's the turn of gases. So what are gases? Gases are invisible and odorless. What do we mean by invisible and odorless? Invisible means that they are not seen. We cannot see them with our naked eyes. Okay? Odorless, they have no smell. So it has no uh, defined smell. So they are invisible. They cannot be seen with naked eyes, and odorless means that they have no smell. Except some gases, these are particular cases and they are very rare. So these gases that are visible, like chlorine gas, you can see the picture here. So chlorine gas has a green color and can be visible. This is an exception, okay? But in general, gases are invisible and odorless. Okay, this is an example about the invisibility of gases. So air is gas, the air surrounding us. So الهواء is invisible. We cannot see it with our naked eyes. Let's do this experiment in order to verify that air is invisible. So look at this figure. What do you observe? We have a hand holding a beaker and it's dipped in a beaker filled with water. Okay? If I hold it straight, nothing happens. However, if I let's say bend my hand a little bit, we observe these bubbles going out from this small beaker. So when the bottle is introduced vertically, mouth down in water, the beaker's mouth is down in water, water does not fill the bottle. So the beaker is still empty. You can see that the beaker is still empty. However, if we incline the bottle in this second beaker, air leaves the bottle in the form of bubbles. So air is found, but it's invisible. We cannot see it and is replaced by water. So first, we hold the beaker vertically. When we hold the beaker vertically, we do not see anything. It's not filled with water. The beaker is not filled with water. You can try it at home. And we cannot see anything. So it's an empty beaker. In fact, it's not really empty. It's filled with air. So, but this air, it's invisible, so we cannot see anything. And the beaker will not be filled with water because we have air inside. However, if we incline this bottle and let the water go inside, air escapes in order for water to go inside. So we observe air leaving the bottle in the form of bubbles and then replaced with water. So this is an experiment showing us that gases or air is invisible. So gases are invisible because, in fact, uh, the gas, which is air, here in this case, was filling the beaker, but we cannot see it. Okay? When we incline the bottle for water to enter, air must leave. So when air leaves, it leaves as a form of bubbles, and water fills the small beaker. So we can distinguish from this experiment that gases in general are invisible, and in this case, particularly air is invisible. Okay, as I said before, this shows that the bottle contains air and is not really empty. So now I want to ask you a question. So how we verify the existence of a gas? How can I know that gas exists? Gas is present. The existence of gases can be proven through their effects. So we do several experiments and we see how gas, let's say, how gas act in order to know that it is present and it exists really. Let's see this second experiment. We have a kettle full of water is placed on fire. The water in the kettle boils. So we put the water in the kettle and we turn on the stove. The water starts boiling. So it will reach boiling point and it will start boiling. So what can you observe? See here. What can you observe? So we can observe the burning of gas leaving the Bunsen burner. So it's we have the gas from the Bunsen burner, and also we see the water vapor turns into small droplets on the lid of the teapot. So if I open this lid of the teapot, I can see small water vapor as small droplets. Okay, we can see bukhar. This is this is water vapor. So it will be as small droplets on the lid. يعني I mean الغطا تاعول بريق الشاي. Okay, I observe water vapor as small droplets on the lid from inside if I open this lid. Okay, now we can conclude that air exists because we saw water vapor on the lid of the kettle. Okay, another application from our daily lives. What do you observe during exhalation in winter? So when you exhale in winter, what do you observe? See this boy. So we observe the water vapor coming from the mouth during exhalation in winter. So we see water vapor. We see bukhar from our mouths during exhalation in winter. So using these three experiments, let's say, or activities from our daily lives, we can know that gases are present and they exist, even though they are unseen or they are odorless. Now we have taken the chapter of mass and density and we are done with it. Now, let's see how to prove that a gas has mass. Let's see how gas has mass. Get a deflated basketball. So I bring a basketball which is deflated, نفسه, and place this deflated ball on a digital balance, which is used to measure the mass to get the initial mass. So I put this ball on the digital balance and I get the mass initial. Now I record the initial mass M1. So I will record the mass. I get M1, which is the initial mass. Now I'm done with this step. Now then, I will pump as much air into the basketball as I can to inflate it. So it was deflated, نفسه. I inflated, so it became now a regular basketball. Okay? Then we must place again the inflated ball on the balance to get the new mass. So I put this inflated ball on the balance again to get its mass, which is M2. So first of all, uh, I get a deflated ball. I measure its mass using the digital balance, and I write it. I write M1 is this amount. Then I inflate the mass. I inflate the ball, and then I put it again on the digital balance and record the mass M2. Now, what do you notice? So, we notice that M1 is less than M2. Of course, because this is deflated. A ball which is deflated has a less mass, its mass is less than that of an inflated ball. Okay? So, the mass M1 was very small. Okay? Thus, why is M2 in fact greater than M1? Because the increase in mass is due to the air introduced in the basketball. So initially, the ball was deflated. It has no air inside. When I inflated, I introduce air inside this ball. So it will become inflated. So that's why we have M2 will be greater because we have the ball plus air inside. So the mass will be greater. The mass will be more than the ball, which is deflated and has no air inside. Thus, we can deduce from this experiment that air has mass like all matter surrounding us. So it has mass, even though it's invisible and odorless, but still it has mass. So to find the mass of air, we can calculate the mass of this air, which is introduced in the basketball. We use the formula M equal M2 minus M1. So in this way, we determine the mass of air filling this basketball. Now, finally, let's answer this question. Are gases fluids? Let's see this experiment. We have CO2 gas in the beaker. Of course, we cannot see it because it's invisible and also it's odorless. Okay, so we cannot see it. So we have here CO2 gas. And we have in the second beaker a candle which is lit. So it's lit and it's burning. So CO2 gas is in a beaker and a lit candle is in another beaker. Now, I want to pour this CO2 from this beaker into the beaker containing the lit candle. So I bring CO2 and I want to pour it in the beaker containing the lit candle. Now, CO2 gas flows into the beaker and the lit candle is put off. So what happened? When I poured the CO2 into the beaker containing the candle blows off. So it's not lit anymore. So how come? Because CO2 flows from the beaker into the beaker containing the candle. So we can deduce that CO2 can flow. So gases can flow. So gases flow. We can generalize a conclusion that gases flow. So this is it. Gases, like liquids, can flow. Thus gases are fluids. So if something can flow, so it's a fluid. So gases can flow and they are fluids. And this experiment we did above illustrates that carbon dioxide is a gas and like all gases, it can flow. Now, how to distinguish a gas from a solid and a liquid? So, what's the difference between a gas from a solid and a liquid? So, unlike solids and liquids, air has no definite shape and has no definite volume. So, it has no shape, it has no volume. It tends to occupy all the available space, like air surrounding us. So, air surrounding us tends to occupy all the available space. So, air has no definite shape. We cannot see a shape for air or for gases, and no definite volume, and it has no definite volume. It occupies all the available space. Mhm. Okay, this will show us how to distinguish between a gas from a solid and a liquid. We have this beaker filled with water, and we have this piston, let's say, and we have a certain volume here, V1. If I applied a pressure on this beaker, so what do you observe? What do you observe? What differs from here to here? So these particles became closer to each other, right? Yes, of course. So unlike solids and liquids, air is compressible and expandable. So we can compress it, and we can expand it. So uh, expandable, like um, when you put on your perfume. So we cannot see it, but it tends, you smell the odor. So it tends to occupy all the available space. So this is meant by expandable. Compressible, we can compress it, like in your home. So the gas you cook with, okay? It's compressed in this bottle of gas. So this is meant by compressible. So air is compressible and expandable. However, liquids are not, liquids and solids are incompressible. They cannot be compressed and cannot be expanded because we cannot increase or decrease their volume. So we can increase or decrease the volume of gases because we can compress it, we can expand it. However, liquids and solids have definite shapes and have definite shapes and sorry, they have definite volumes. We cannot change their volumes, so it's not compressed, neither expanded. Both solids and liquids are incompressible and non-expandable because we cannot change their volumes because both have definite volume. However, gases have no definite volume, so we can increase or decrease their volume. Thus, they can be compressed or expanded. So this is all for this chapter. Hope everything is clear. Please, if you have any questions, don't hesitate to contact me. Thank you for listening. I hope to see you soon. Bye bye.